recording.
Okay, so just a little background here. This quadratic here, we know it's like a parabola shape, right? And factors of 6 are 1 and 6, negative 1 and negative 6, 2 and 3, negative 2 and negative 3. Which pair of these adds up to 5? 2 and 3, right? So the middle terms, 2x and 3x, add to 5x. This quadratic factors, okay? And if you can factor, it's nice because you get integer values and you can easily put them on the graph. So from this form, which is standard form, I get where it crosses the y-axis, this last number. From this form, which is a factored form, okay, I get values for x that make this 0. So negative 2 plus 2 makes it 0, and negative 3 plus 3 makes it 0. So if negative 2 and negative 3 are my zeros for x. Okay? So if we can factor, we would. But you can see that a parabola sometimes crosses through decimal values. You can't factor for those. And so we need something else. This is completing the square then. Alright? So, with completing the square, there are a couple things you just have to memorize or you can't do it. Okay? You have to memorize. The perfect square trinomials. So I'm going to write a little note on that. This is kind of like the thing you have to memorize is x squared plus 2 times b times x plus b squared. Where does that come from? That comes from multiplying x plus b, x plus b. That is a perfect square trinomial. That's what we use. We create this pattern with these so that we can solve with a square root. Okay? Do you guys know that x plus b times x plus b is just x plus b squared?
Yes.
Yeah. Okay, good. The other, there's 2 of these actually. The other one has a negative and a negative here and here and here. So the first sign is a negative with the other one. Okay, but they're so similar and both of these are pluses, so I'm just going to leave that up there. Okay? If you don't have this memorized and you don't understand that these are the same, you can't do this. You just can't do this. Okay? So, if you do have them memorized, you can. Let's do it. Alright, the 3 doesn't actually work for the b squared part, so I'm going to move that out of here. Okay? X squared plus 5x plus something equals negative 3. Okay? Now, this piece does match that piece. Good. This piece is the 2bx. 2 times b is 5. See the 2b? So what does b have to be if 2 times b is 5?
2.5.
2.5. So what would this have to be?
2.5 squared.
Yeah, 2.5 squared. So we do 2.5 squared here.
6.25. I did that in my calculator.
Okay? And if we add something to the left side of the equation,
It has to go on the right side.
yeah, we want to add the same thing to the right side. Okay? Now, this right here is a perfect square trinomial. We've matched it, right? Yeah.
I always get stuck on why wouldn't you subtract the 2.5?
Like move this to the other side?
Yeah.
Oh, because we have to have these 3 pieces to turn it into this form. So only these 3 pieces turn into this form. So if I took this piece and I subtracted it off to the other side, then I wouldn't have these 3 pieces and I couldn't make this. The goal is to make this,
Yeah.
to turn it from here to here.
So, could you put in a number for b that wasn't, for b in that b squared spot that wasn't necessarily actually b squared, but still let you factor and still factor it?
Well, this number here has to be, we have to get this information from the 5. It has to be half of 5 that we put here and square it. Okay?
Mhm.
Because that's the only thing that matches this pattern. If 2b is 5, b has to be 2.5.
Right.
And so that's what we have to square there. So we can't put we could work that out. It's what, 6.25?
Yeah.
Yeah, we could put a 6.25, but what do we put here? 6.25?
No.
No.
2.5.
This is B, 2.5, right? So when I change it from this form to this form, I have an x here, and then I have a plus b. What's b?
2.5.
Yeah, 2.5. So usually I write it just as 2.5 squared to remind myself that I put b here, not b squared here.
All right.
Okay? Yeah. All right, so b squared is what we get when we multiply these together. But I don't want to multiply them together because I want this form. Because we can use square roots to solve with that form. Okay? On this side, however, -3 plus 6.25 is what I really need to do here. All right? So I need to simplify this side a little bit. So I'm going to make that as what? No. 6 minus 3 is just 3.25. Okay? So I simplify that. Everyone good with that?
Yes.
Yeah.
Okay. This here, x plus 2.5. And that's squared. How do I get rid of a square?
Square root it.
Yeah, I have to root both sides. Okay? Now, something that a lot of people forget is when I root both sides, this side has to be a plus minus. Okay? So x plus 2.5 equals plus minus square root of 3.25.
Why is that again?
Why is it plus minus?
Uh-huh.
Yeah, okay. Well, first of all, it's a parabola, so we're expecting two answers. This
Right.
is how we get two answers, but
Right.
here's why. Here's why. If something's squared, that means there's a value for x that makes this a positive number that's squared, and there's a value for x that makes this a negative number that's squared, and we still get the same thing. So
Right.
before I put square roots here, it was 3.25. There's a number here that gets me 3.25, or the square root of 3.25. Hold on a second. I'm gonna just pop out over here and use an example that's easier to think about with simpler numbers, not decimals, okay?
Uh-huh.
So let's say I have x squared equals 16.
Yeah.
What number goes for x that would equal this?
4.
4 and?
Oh, -4.
Yes, -4 squared is also 16, isn't it?
Yes.
So there's two numbers. When this is squared, there's two numbers here that equal 16, not one number.
Uh-huh.
Right? There's a positive and a negative version of x. That's if I just have a single x here. And if I took the square root of both sides, I would have to get x equals plus and minus 4, because 4 squared is 16 and -4 squared is 16.
I see. Okay.
So yeah, so that's why we have a two answers here, plus and minus answer. Okay. So when you take the square root of both sides, this side has to be plus or minus. Okay. Now subtract this 2.5 over,
Sorry.
and this cancels, and so my values are for x are going to be -2.5 plus this, and then -2.5 minus this. Someone do some calculator work for me. What's -2.5 plus root 3.25?
The root of 3.25?
Negative 0.697.
Negative 0.697. And if I do a negative here instead of a positive, what do I get?
Negative 4.303.
And was this -2?
Yes. These are rounded off from.
Yeah, okay. So these two answers. Does this parabola cross at nice numbers? Not really.
No.
It crosses somewhere between, about just over -0.5 and just over -4. That's where it crosses. That would help us graph. Okay?
I mean-
But this parabola, it crosses up at +3, and then it crosses here on the x-axis on these two values. So completing the square allows you to graph any of these, even if they aren't integer values where it crosses. So if we can factor, then they're integer values and life is good. It's easier. If we can't factor, then we have to do something like this. There's also quadratic formula, which we're going to learn. But this is a really good technique because we also use this to do a lot of other operations in math. Okay, besides just solving for x. All right, that's that problem. Let's get to this one. All right,
Should I keep recording?
sure.
All right.
Because this one has a couple different things going on in it. Do you see that we have a 2x squared rather than x squared, which is what my pattern needs to be? So I'm gonna add the 5 to the other side. I just don't need it there. It doesn't really work for what I'm doing. So I just add the 5 over. 2x squared plus 2x. I'm gonna leave a space there, equals 5. Now, I have to have an x squared here. So what we do is we divide out 2 from both pieces. That goes to the outside. So I have a 2 outside, then I have an x squared plus
X.
x plus something. And that equals 5.
5 plus something. Yeah.
What completes the square here?
Let's see. That would be 0.25. Since 1/2,
Yeah, because this is a 1, right?
yeah.
So remember, we're trying to make this pattern match. So 2 times b is 1. So what's b if 2 times b is 1? 1. What's half of 1?
1/2.
0.5, 1/2.
1/2 times 2 is 1.
Yeah.
So b is 1/2.
Right.
Okay? So I have a 1/2 squared here, or a plus 0.5 squared. That's what completes the square, the perfect square triangle. Okay? So this can now turn into x plus 0.5 squared. I just go to the factored form of this. Okay? Remember, these are the same because these are the same. And we matched this so we can do this. So we're always trying to do this so we can turn it into factored form. This is now in factored form, but remember I added something here? What do I have to add over here?
2 times 0.5 squared.
Yeah, this is the most common error I see with these, is that people add a 0.5 squared and a 0.5 squared and they think they're done. But this 0.5 is in parentheses that is multiplied by 2. So I'm actually adding double 0.25 squared over here, because the 2 outside controls this too. So I have to add a 2.0.5 squared on the right side, because it's 2.0.5 squared on the left side. Alright, so now I have to simplify this side over here. 5 plus, what's 2 times 0.5 squared?
Let's see. 2.2. No, sorry. That would be plus.
1/2 squared is 1/4. 0.25 times 2.
So 1/2.
1/2.
Yeah.
Okay, so we get 5.5 over here.
Wait. So 0.5 squared is basically just saying half of 0.5, and then you just multiply it by 2
0.5
again.
squared isn't half of 0.5. It's 0.5 times itself.
Right, but since
That is half. Half times half.
Yeah, right. 1/2 times half.
It's half.
Yeah, it kind of works out that way in this problem. So 1/2 times 1/2
and then times 2,
is
so
1/4.
times 2
And
would
then times 2
gets you back to 1/2.
is 2/4 or 1/2. Yeah, so this piece right here is 0.5. And so 5 plus 0.5 is 5.5.
Right.
Yeah. You know, you can of course do this on a calculator, but it's good brain work here. All right, so we simplified this side. Now let's divide out a 2 and then solve for the square root. Divide everything by 2. And so we get this. What's 5.5 divided by 2?
2 point.
2.75. Okay. So we have x plus 0.5 squared 2.75. And now we can take the square root of both sides. Square root of this cancels the square. Square root and square cancel. This has to be plus minus. So I get x plus 0.5 equals plus minus 2.75 in the root. Move this over. So subtract off of both sides, and then these are our answers. So someone do calculator work here for me.
X equals 1.16.
And the negative one?
Negative 2.16.
Okay. So those are our two values for x. Do I have confirmation? Anyone else getting those numbers?
Uh,
I think that is a yes.
2.75, like 5.5 divided by 2.
What are you working on?
How did you get the 2.75?
Oh, 5.5 divided by 2. Yeah, because half of 5 is 2.5, and half of a half is 0.25. So 2.5 and 0.25 together is 2.7. Yep. All right, great. The key idea here, though, is that we're using this pattern to fill in something so that we can change the form and solve the square root. That's the key idea. All right, thanks for recording. You can stop.